Hello again. You've watched me clean a burette and get it ready to titrate. Now I'd actually like to do a titration. And so there's two things that we need to know about this titration. First, that we're trying to figure out the concentration of the sodium hydroxide in our burette. Our bottle claims, again, that it's 0.122 molar. That's what we thought it was in the carboy, but periodically we need to standardize it, make sure it's actually still that concentration. So what we do is we use a substance called KHP, potassium hydrogen phthalate. And what you see here is a clear and colorless solution. Potassium hydrogen phthalate is a solid, but when I dissolve it in water, it makes a clear, colorless solution. And it's an acid. So we've got sodium hydroxide, the base, in our burette, potassium hydrogen phthalate, the acid, in our flask. And I'm not interested in the amount of liquid in the flask. What I'm interested in is the grams of potassium hydrogen phthalate, the 0.225 grams that go with this trial. So I've got an acid, I've got a base, I've got a burette and a flask. The next thing that I need is an indicator. An indicator that we're going to use for this titration that works very well for acid-base titrations is called phenolphthalein. Phenolphthalein has a nice mouthful of a name. It's kind of fun to spell. But just a little bit of phenolphthalein in my flask, and I'll be able to see a change in my solution. Right now, it's clear and colorless, but something will happen as we go through our titration. So what I'm going to do is I'm going to lower the burette down so that the tip of it is inside my flask. There's no reason to make a big, huge mess by dripping it from really far above. So here we go. And then the next thing I'm going to do is I'm going to kind of clean out my space just a little bit. I've got some liquid, but this white paper towel that I just put underneath my burette is going to help me see the color change that's about to happen. So as I titrate, let's see what happens. I'm going to add, oops, let's make this so you can see it a little bit. And a little lower. So I'm going to add some sodium hydroxide to this flask. And as I do, you can see maybe a little bit of pink forming in the beaker. Let me put the white paper underneath it and see if that helps a little bit. Watch for the pink. And I'm going to drip it slowly. We can see pink and pink and pink. And I'm just going to swirl as I titrate. And eventually as I titrate, that pink is going to stay around longer and longer. So I'm going to stop my titration for a moment. And I'm going to swirl, and I'm going to see that the pink is gone again. But as I keep going, it will get closer and closer to persisting. So the pink's already sticking around a little longer every time I titrate, and a little longer and a little longer. Should be getting pretty close now. I can tell the longer the pink stays around, the closer that I know that I am to what's called the end point, the phenolphthalein end point. Phenolphthalein changes color. So here we go. Let's keep trying until we get closer. Ooh, getting close. And what I'm trying to do is I'm trying to find the closest point to where that color changes, where one drop makes it completely change. And so that's why I'm going kind of slowly. The slower I go, the more precise I can be in the end. And with acid-base titrations, they're a little bit more forgiving. If you're fast, they're not going to really mess you up. But other types of titrations, when you titrate fast, you'll get really bad results. So you want to get used to kind of going slow as much as you can. So here we go. That pink cloud is sticking around a little longer and still not that great. Here we go. Keep working. And by the way, when I calculated this, I'm finding a lot smaller or a lot larger amount of sodium hydroxide than I calculated, which really does mean that this sodium hydroxide over time isn't 0.122 molar. It's something less at this point. So I'm not super surprised by that, but I am aware. Oh, we're getting really close. That pink is sticking around. Almost there, almost there. So close. Ooh, that was nice and pink. Let's see if it can stick. Uh-oh. See that fuchsia color? I went past my endpoint. That is very pink. I would want to shoot for something lighter than that. The good news is phenolphthalein tends to be a really quick change, and a drop can make it go from really light pink to really bright pink very quickly. So I'm going to hope that this trial, I just added an extra drop and it's not going to affect my volumes too much. We're going to find out soon. By the way, before I started, I took an initial Burette reading, and I hope that you guys were able to figure out from the pictures in the modules that it was 4.25 milliliters. Now I'm going to go back up and I'm going to read my Burette. And again, I'm reading from the top down. I'm noticing that it's at 13.50 milliliters. So I'm going to go ahead and record that into my lab notebook, 13.50. Remember, Burettes record to the hundredths place, so I'm making sure to put hundredths on there. And then I can calculate the amount of sodium hydroxide added and do my calculations from there. So check back into the module, and you're going to see some titration data, some pictures that you can get your own initial readings and final readings, and you can tell me whether I was precise or not and whether you needed to scroll or to sort out some trials. But that's all you have to do a titration. You just have to drip in your stuff little by little until the indicator changes its color. Right? I added phenolphthalein, it went from colorless to pink, it changed its color, I quit, and I took my readings. That's the way titrations go.